Hello and welcome back. So, what have we discussed so far and where are we at right now? So, chapter 2 again, atom, nucleus, electron, neutron, proton. Items with a negative charge have gained electrons. Items with a positive charge have lost electrons. Okay, so when we have an atom that has a negative charge on it. We have one atom that has a negative charge, okay, and it comes close to or in contact with another atom, or it's in the same substrate, or it's in the same direct same area. The material's made of the same thing. Then those electrons from the negative atom will want to move. Okay, they'll want to move. They'll want to go away from their like charges. They'll want to go to the opposite charge, okay? They'll want to put themselves in sort of an equilibrium state, okay? And when those electrons move, those are the free electrons once they move, okay? They're usually the outermost ones out here on the outer band, okay, of this atom, okay? That might be more information than you need. But they become free electrons, okay? The ones most able to move in an atom become free electrons. And an electron that moves, an electron that begins to move, that is moving at a particular distance per unit time, and that's what we call an electric current, when electrons begin to move. And it's not usually out here in the middle of space, out here like this. It's usually it's in a material, okay? It's in a material such as, in this case, we'll call it copper, okay? So that's actually moving from one atom to another atom, okay? And this might not be totally positive like that. It could just be neutral, okay? But one side just ends up getting more electrons and has a higher negative charge than the other atom. So the electrons want to move. And therefore we get a current once we have these electrons moving from atom to atom to atom to atom to atom. Okay? These atoms don't take up the entire diameter of the copper wire. This is just to give you an idea of what's going on, not to scale. Okay? That is an electric current. So electric current is measured in terms of amperes, okay? Amperes, which amperes are made up of charge per unit time. Charge is measured in coulombs. So current, I, is equal to Q divided by T, okay? Q is measured in coulombs, and I is measured in amperes, hold on, I might be spelling that wrong, amperes, oh, is it E at the end out here? E-S, amperes. Current, I, is measured in amperes. Charge, Q, is measured in coulombs. Charge divided by time is current, okay? And that is the SI unit for electric current, okay? 1 amp is equal to 1 coulomb per second, okay? 1 amp is equal to 1 coulomb per second. All right? And a coulomb carries a charge of 6.24 times 10 to the 18 electrons. That's a whole lot of electrons. Can't even begin to tell you what prefix of the unit that is. Okay, so that is that. Let's recap a little bit. Let's say items with a negative charge have gained electrons. Items with a positive charge have lost electrons. This is the atom. This is a hydrogen atom because of its what's in it. This is the nucleus made up of a neutron and proton. This is the orbiting electron, okay? Electrons are the things that move only, okay? So as you get a negatively charged atom, the electrons on the outer shell, they want to move to a proton, or I'm sorry, they want to move to an atom that has a higher charge, okay? Has a more positive charge naturally, okay? They move with a particular force. We call that the Coulombic force, okay? And when those electrons move, they're called free electrons. They're called free electrons, and as they move with a charge, okay? That charge is measured in units of coulombs, okay? When they move a particular distance divided by time, or when the charge moves with time, we call that an amp. 1 amp is equal to 1 coulomb per second. And 1 coulomb of charge is equal to about 6.24 times 10 to the 18 electrons, okay? 6.24 times 10 to the 18 electrons. That's not just one electron moving there, okay?